Alright, so we are going to work on 8.3 tonight, but remember, as I told you guys in class today, we're going to take 2 days to do this, so please, don't give up on the first day. This one will take a little bit of practice, but we are going to use the stuff that we've done before. I will try to break it down to easier terms first, and then we'll apply those same concepts to these larger problems, but the same concepts are going to be applied, so please, hang with me. A couple things I want to review before we get to the big problems. If you had problems like this, x over 5 equals 7 over, let's do a different number. Let's do 8. And then we had 4 here. How could you do this? If you remember back in middle school, you can cross multiply. And that's just a fast way, a quick way of doing it. But actually what you're doing is you're timesing this side by 5, which cancels these out. So you times this by 5. But you also have to times this side by 4 to cancel these guys out. So you end up timesing it by 4. So what the person saw is instead of doing all that work, you could just cross multiply. They came up with that little thing. So it was x over 5 equals 8 over 4. They just saw, hey, you know what? You ended up multiplying the 8 times the 5, and you end up multiplying the 4 times the x, and the other two cancel out. So you end up with 4x equals 40, divide by 4, and you realize that 10 equals your x. That was something that you could do. So cross-multiplying is something we're going to talk about. Another thing I want you to realize, if I have 1 tenth, and I add 2 tenths, and it equals 3 tenths, that is a true statement. Basically, once I have all the denominators being the same, they really don't matter anymore. All I have to do is make sure that 1 plus 2 equals 3. We're going to use that concept in just a little bit. Our denominators aren't going to be the same. We're going to make them the same. And then once we make the denominators the same, we really won't care about them anymore. We'll just care about the top being true. I hope that makes sense. So here we go. Let's try these first couple problems. All right, so rational equation. Now, all the stuff that we've done before have been expressions. Tonight, we're going to have an equation. We're going to have a left side, and we're going to have a right side, and all the stuff that we've done before applies. Whatever you do to one side, you got to do to the other. So here we go. The first thing this guy, this person does is Randall over here, basically, he does what I talked to you guys about. He does it kind of the long way, where he multiplies both sides by the x plus 2 and the x minus. So he comes over here, he says, I have to multiply this by x plus 2, so these two cancel. So then I have to multiply this side by x plus 2. But then I need this guy to cancel, so I need to multiply by x minus 5. This is all over 1, by the way. One's in top, one's the bottom. This can cancel, but then I need to multiply this side by. So he takes the long route. The same thing is going to be accomplished by Sully realizes, hey, I have two fractions that are set equal to each other, so what can I do? I can just cross multiply. And he multiplies the top times the top, or the top times the bottom here, and the bottom times the top over there. Cross multiplying. That's why we end up with this right here. The next step he does is just redistributes all this stuff out. When you redistribute, you should get to this. Distribute this out, and you get to this. Then he says, okay, let's combine like terms. When he minuses x squared from this side, he minuses x squared from this side. This cancels out, this cancels out. So he's left with just a negative 25 equals 3x plus 2. He then subtracts 2 from this side, subtracts 2. A negative 25 and a negative 2 is negative 27 equals, this is gone, so just 3x. He divides by 3, and gets x equals 9. Eventually you're going to see Randall gets to this same point. Randall gets to that same point, which was right here. Let me erase that. Oh, sorry. Actually, Randall gets to the same point. It's right there. This step right here, once he gets to there, everything else from here, those are the same problems. You'll notice it equals the same. Randall just took the long time because he did undoing this side, and then redid it to the other side, undo this side, and then had to do it to the other. Sully just does the quick step, which is just cross multiplying. You are allowed to cross multiply as long as you only have the original problem is one fraction, two fractions, and they're set equal to each other. If you had x over 5 equals 7 tenths plus 4, you cannot cross multiply this problem. Yes, there's one fraction. Yes, there's two fractions, but there's something else out here. You can't have something else out here and cross multiply. So the only way this can work is you have an example like this where it is two fractions that are set equal to each other. Boom, you can just cross multiply and solve for your x. All right, now this problem we're going to take some time on. So again, we have two fractions that are set equal to each other. So what can we do to solve this problem? We can just cross multiply. And if you notice, that's what Sully does. And Sully leaves it in factored form in the beginning and leaves this in factored form in the beginning. And notice he is talking about restrictions. Right here he's saying, hey, don't forget, before we should cross multiply, we should set restrictions and we should say, hey, x, because of this, it's not allowed to be 0 in the denominator, it can't be a 5, and it can't be a 2. This one, it's not allowed to be a 5. We already have that restriction, so I don't need to double up. So again, you definitely should do your restrictions and then go ahead and cross multiply. After he cross multiplies, he distributes stuff out here, and that's where he gets to right here. And I don't agree with his next step. If it was me, I would simplify these next. And I would make that x squared minus 3x minus 10. And then I would go ahead and do x plus 1, and I would distribute that. Remember, you're going to have to do it. Every one of these things has to touch. So there's 3 terms here and 2 terms. Everyone has to touch all these. So you're going to have to do 6 different terms you're going to come up with when you distribute that back out. And if you look, 1, 2, 3, 4, 5, 6, he ends up with 6 terms, and then he combines the like terms. So x cubed doesn't have anything in common, so it stays x cubed. X squared so you have to be careful with this book because they do, sorry I paused the video, they do some steps here kind of together. To me, I would combine these like terms. I simplify everything on this side first. So I would combine all like terms, get my answer, and then bring these guys over. They do that in one step, so I will show you. I'll break that down a little bit more for you over on the side. So meaning I would combine, so this would be x cubed. I would combine this with this, which would be a negative 2x squared. Then I would combine my negative 10 and my negative 3, which would be negative 13x, sorry. And then add minus 10, and that would equal x squared minus 25. Well, then I would minus an x squared, and when I minus an x squared, that would combine here, and I would add 25, and I'd add 25 to where they are common, they have like terms, and so I get x cubed minus 3x squared minus 13x plus 15, and it would equal 0. That's where they got to this point. So that's the steps they missed. They then make their p's and q's. P's are all of the factors of the last number. Q's are all the factors of the first number. Well, that's a 1, so that's why it's only plus or minus 1. So the list of possible roots, that should be old material that we're just reviewing, are from right here. He then uses synthetic division to check them, and when he checks 5, it works. If it was me, once I got one that worked, I would not do what he did and check other numbers like that. I think that's a waste of time. Once I check 5 and it works out, I would know my leftover, so I would know that it would factor into x minus 5 would be one of my factors. And then my other thing would be x squared plus 2x minus 3. And what I would do personally is I would factor this guy on my own because I can factor it. I need 2 numbers that multiply to 3, but different signs subtract to 2, so that would become an x plus 3, x minus 2, or x minus 1, sorry. X minus 1. So I would look at that, and that would be my my roots, or what would equal, when this equals 0, my roots would be 5, because that makes that 0, negative 3, that makes that 0, and 1, like he found. But then at the end, you have to check your answers. So what he did is he plugs it in to the original equation. You notice all he did is he takes the x's out and he puts negative 3 in that place. Took the x's out, solves it, and yes, 2/8 equals 2/8. So yes, it works. He checks 1. And when he checks it out, it works also. Check. Again, all he did is replace the x value with the 1. And just takes it and simplifies it. You should be able to look through this work and make sure you understand it. So how come he didn't check negative? How come he didn't check 5? Because already at the beginning, we knew 5 was out. It was part of my restrictions. So you do have to check even the ones that aren't part of the restrictions, because there are things called extraneous solutions, which means it looks like they would work, but maybe a sign somewhere in there got mixed up and it wouldn't work. So you do have to check them, especially when we start getting with squares, because sometimes you have a square on one side and not a square on the other, and so you get a positive on one, you get the negative x on the other one, and then it doesn't work out. So it is weird, but there are extraneous solutions. So you do, yes, this is a must. You must check all your answers. The reason he didn't check 5 was because it was already part of our restrictions. So he knew it was thrown out. So your answer for this question would be x equals negative 3 or 1. And that would be your final answer. But it would take all of this work, ladies and gentlemen. Like I've said, please use paper. Don't erase. If you try synthetic division and it doesn't get you, remember it has to be equal to 0. When you do synthetic division, if it doesn't give you a 0, leave that work on there. Don't scratch it off. Don't erase it. Just go to the next one and do a second one underneath it, kind of like he did here with all these. But just keep going until you finally get one that's 0, and then use this right here to create your other equation, and then factor that thing. We'll have some practice on this tomorrow. We need to really practice on this and try these out. All right, so that talks about the extraneous solutions. Now, they talk about how he graphs it, and if you look, when he puts this thing in the calculator, when does what he did is he took our original equation was x plus 5 over x minus 5, x plus 2 equals x plus 1 over x minus 5. All he did is he moved this entire thing to the other side. How did he do that? Well, how do you undo, since this is all technically a positive number, you just subtract x plus 5 over x minus 5, x plus 2, and that cancels out on this side, leaving it with 0, equals, and then when you move it, you have to do it to the other side, you get minus x plus 5 over, let's see, x plus 5, or x minus 5, sorry, x plus 2, and so he ended up with this equation right here. That's how he ended up with this equation. He just took this whole thing and moved it to the other side by subtracting the whole thing. That's where we get this minus all of that. All right, so when he puts that in the graphing calculator, it graphs a funky shape like this. But if you notice right here, we're looking for when it equals 0 to solve this. That would solve this equation. So if you look, boom, it equals 0 right here. It equals 0 right here. But if you look at the number 5, 1, 2, 3, 4, 5, there's an asymptote. Okay, and if you look the other one, there's also another asymptote at negative 2. That's from this one right here, the plus 2. So exactly like we thought, this should work out. There's a solution, there's a solution. It should hit here is what when we factored it, but it's a asymptote, so it doesn't touch. All right. All right. All right, so we're going to talk about this last section, hopefully just 5 minutes. So this is another way of solving it. At the beginning of the class, I told you when you have 1 over 10 plus 2 over 10, it equals 3 over 10, because all you really care about, once you have common denominators, you can put that over one denominator, and all you need to do is make sure that the tops line up, which is why 3 over 10 equals 3 over 10, because you just add these guys. So what happens is once you get common denominators with all of these guys, you don't really care about them anymore, and you just want to make sure that 1 plus 2 equals 3. So that is what we're going to do down here, but on a much larger scale with some nastier things. We just have to make sure spacing, writing, all those things don't get in our way. So what we're going to do is we want to make sure that this denominator is the same as this denominator. And once we make those have common denominators, kind of like what we did, least common denominator for addition, once we make these guys have the same denominator, we won't care about the denominator anymore. We'll just solve the top and make sure that it works out. So here's what I'm saying. Sasha realizes that, hey, this already has an x minus 4. So what is it missing? It's missing the x plus 2. So what did she do? She multiplied the top and bottom by x plus 2. That's this step right here. She multiplies both top and bottom by x plus 2. Now right here, this guy and this guy have the same denominator. So in her next step, all she does is she can go, don't worry about this. Yes, that's why it's true. She multiplies, what she's able to do is multiply by x minus 4 and multiply by x plus 2. And if she multiplies that, this cancels out, and all she's left with is x plus 4. But she does it to the other side also, and that cancels out this denominator because they have the same denominator. So when I multiply x minus 4, x plus 2 on this side, I have to do it to this side. And what happens is both denominators cancel out. Essentially, what I like to think about is once my denominators are the same, I don't care about them anymore, and I just worry about the tops. When does this equal that? And you'll see that's this next step that she gets to here. Again, once she gets there, she starts combining like terms and making this thing equal to 0. So she moves everything to one side. So actually, she takes and she minuses 2x, minus 2x, cancel out, she minuses 4, minuses 4, and that's where she get x squared plus 1x when you combine those, and a minus 2 when she combines those. She then factors this, so she can see the factors, which are x minus 2 and x plus 1. And she knows that negative 2 is part of her restrictions. I should have talked about that at the beginning. I'm sorry. I'm trying to go quick. So she knows that the restrictions, before she does anything, she does her restrictions. She knows it's not allowed to be 4 or 2. So when she does this, she knows that this one's canceled out. So all she has to do is check the 1. When she checks the 1, it works out. So her final answer is x equals 1. Again, how do you check? You just plug in 1 for all of your x's and then solve. And the reason this one works is technically in this problem, before she did anything right here, before we did this style, could she have just cross-multiplied in this style? Yes, she could have just cross-multiplied and done the same thing. It might have taken a little bit more work. It might have been some more of that solving with by using synthetic division, but she could have just cross-multiplied because, yes, this is one fraction, and this is one fraction. So I didn't need to necessarily teach you the new way, but the reason we taught you the new way is for this type of problem down here. I'll get to it. I'll go back to Jake in a second. Right here, are you allowed to cross-multiply for this problem right here? No, you're not, because I do not have 2 fractions set equal. I have 1, 2, 3 fractions. So boom, I cannot cross multiply. So what do we do for this style of problem? We are going to make all the denominators the same. We find the greatest, so they factor right here. They didn't factor. We factor. We figure out that it's x minus 4 is one of my denominators. Other denominator is x, and x minus 4. So their least common denominator is going to be x minus 4. I need to make all of them become that. So if you look right here, they make it become x minus 4, x minus 4, x minus 4. And once I get to that step, I can just not worry about the denominators anymore, and I can make it become right here. That's what I would do. 6 plus 4x minus 16. 6 plus 4x minus 16 equals 2x. Combine like terms, solve. Now the only thing they should have done is they didn't list restrictions, which we should have taken care of at the beginning. They also should check 5 to make sure that it works, which means you plug it back into the original equation and make sure that it solves it. So that's going to be the beginning, and then we're going to do some actual more problems on the next video where I actually do them. Tomorrow in class, you're going to practice this a little bit more, but like I said, we're going to have 2 days, so please take your time. Finish any of the skills work that you haven't finished yet. I tried, like I said, try to keep this to 20 minutes, and then tomorrow night, we're going to be going through more of these problems. But if you can look, don't be afraid by these guys. This is, yes, you should be able to look through and understand this problem. And in this problem again, he's making the denominators the same. Boom, they're the same. Boom, they're the same. Boom, they're the same. And once they become the same, you can just basically mark this off. And then up here, you just combine all the like terms on this side first, set it equal to this side. Once you combine like terms on this side, then you bring all of these terms over and combine them and set it equal to 0. That's eventually what you get to. Once you get down there, he pulls out a 2x that they all have in common, greatest common factor. Then once you do that, you're left with this. He then factors this into a problem like that. You should be able to go through and understand every one of these from one step to the next step. Notice after we did set some restrictions. We should know the restrictions from up here. It's not allowed to be 0 or 4. So if any of those are my answers, I can throw them out. So 0 or 4 are gone down here because they were part of my original no-nos. So then all we had to do is check 5, checks 5, and it works out. So boom, x equals 5 is my final answer. All right, so please, again, like I said, we'll go through some more of these. Have a good night. Don't freak out. Relax.